Kelmarsh wind farm extension. The wind was characterized using the 2018 data. The Kelmarsh 10-minute data was analyzed, assuming as it was recorded from nacelle height of 78.5 meters. This showed the mean wind speed of 6.08 meters per second and a turbulence intensity of 0.16. The surface roughness was calculated using the log rule. Data was analyzed dynamically, as such any changes were promptly backlogged into previous analysis. As such, power law index was calculated using the wind speed at a hub height of 41 meters, which we will come back to later. 16 bins were created for wind directionality, and using the frequency function were placed in each bin, for example 0 to 22.5, 22.5 to 45, etc. As we can see, west and west-southwest had the highest frequency. A shear profile using the log rule is displayed to show the change in wind velocity with a change in hub height. MCP analysis was conducted, however there was a mismatch in data for Kelmarsh and other weather station, as it was 10-minute data and data from other weather station was hourly. As such, the 10-minute data was periodically averaged to convert to hourly. Additionally, there was some missing data from Kelmarsh and weather stations alike, which had to be ignored. As such, the data was fully matched to right date and time. Monkswood showed the highest correlation with Kelmarsh, even though it was roughly 130 miles away at a mast height of 41 meters. As such, this was used in the wind characterization analysis. This could be due to other weather stations being situated in a city. For example, Camden is in Coventry. Further correlation could be carried out using the wind directionality. The P90 wind speed was estimated using the 10-year data from Monkswood, which was further analyzed to find the mean wind speed correlating to each year. This was then scaled to Kelmarsh at 41 meters and then at 85 meters. We'll come back to the 85 number later. The mean of the 10-year wind velocity was found as 6.75 meters per second and the standard deviation of 0.22. The P90 standard deviation was assumed to be 1.28 for normal distribution. As such, the P90 wind speed was 6.46 meters per second. This is the market research into different size turbines. Initially, we were aiming to install 2 turbines to reduce the maintenance required. As such, 2 7.5 megawatt turbines were to be installed for power rating of 15 megawatts, which is higher than the current wind farm rating of 12.3 megawatts. However, it is impossible to find location that would prohibit a 7.5 megawatt turbine with an average rotor diameter of 160 meters to meet the shadow flicker standard. As such, a smaller generic turbine of 3.4 megawatt with a rotor diameter of 119 meters was selected. The hub height of 85 meter was borrowed from the standard height of GE 3.4132 used in P90 wind speed analysis. This is the power curve of a generic 3.4 megawatt turbine. The rated wind speed of 12 meters per second and maximum tip speed of 72 meters per second was borrowed from Senvion 3.2 M115, leading to a power coefficient of 0.29, which is about right for this size of turbine. To select the location of the turbines, the 10D shadow flicker 100-degree leeway to the south, the 1.1 times the tip speed height setback from roads and major power lines of 150 meters, and 3.5 and 4D wake interference with other turbines was considered. The contested properties marked by a purple marker are to be bought or rented. The sound power from turbines at nearby properties was calculated, with additional properties being added into the analysis. Clipston Garage showing the biggest change at 7% after the new turbines. Other close by 10 properties were also marked for noise check. Altogether 3 properties were above 45 decibels, including Hassel Beach Garage and Bassett Lodge Farm. The predicted annual yield at P90 and P50 is 23,000 megawatt hour and 26,000 megawatt hour respectively. Now moving on to the risks and mitigation. There was a lot of missing data which could have secured the analysis. Furthermore, the MCP analysis may not be as accurate, as Monkswood is 130 miles away from Kelmarsh, whereas other weather stations are much closer. Further analysis of wind directionality or average gust must be carried out. Turbines with power rating greater than 3 megawatts have rotor diameter greater than 110 meters, which leads to properties that are contested due to shadow flicker standard. We may not be able to place the turbines in the selected location if we cannot reach an agreement with the owners. Possibly selecting a smaller size turbine may help. Additionally, the extension may interfere with flight patterns of bird, as such a survey of bird migration pattern must be carried out.